Hey guys, Mr. Bowman here. Today's learning objective is in yellow. We are learning to determine the generalized formula of a given equation, and this time around we're specifically focusing on a generalized x variable. And what that means is it is a variable that relates to the x-axis. So I've got two graphs here. So these two graphs, they could have come from a previous question, and we're going to generalize both of them, and I'll show you what that idea of generalization means. So let's start off with the parabola, and then we'll move on to that trig graph. So the parabola, I guess the first step, perhaps in a previous question, we've drawn the new section of a roller coaster or an obstacle course, whatever the context may be. So we've drawn that, and we've now got to come up with its equation. And so first up here, I can't see the x-intercepts, so I'm not going to go near the factorized method. I'm just going to focus on the vertex method for determining that formula of that parabola. So vertex method, and that is y is equal to a x plus b squared plus c. And we can identify the vertex. We can visually see that. So that's at 11, 10. That tells us how much it's moved up or down. So C value, how much is it moved up? Well, our C is going to be equal to 10. The B value, how much does it move left or right? It does move right by 11. So B is going to be negative 11. And A, we need another point. We can go ahead and calculate that. But I can see a clear point there, which is at 10, 7 that I'm going to use to finish off this equation. So we also know that x will be equal to 10 and y will be equal to 7. So let's put that all together. So 7 is going to be equal to a 10 minus 11 squared plus 10. So we put everything in there. So we've got our c value, our b value, our x value, and our y value. Once we've got there, we can go ahead and solve this. So that 10 is going to become on the other side. So that's going to be 7 minus 10, which is negative 3, times, this here is negative 1 squared. So times negative 1 squared. Negative 1 squared is 1. 1a is just a, which means this is an easy solve. A is going to be equal to negative 3. And as a result, that means the regular formula will be negative 3 x minus 11 squared plus 10. So that's our starting point, just to get a bit of context about this. And what that means is that's the formula for this exact shape. And we can see here this has a distance of, let's say that's 2 meters. But what happens if we want to change that? What if we wanted d for distance, meters long? So I guess currently the total shape, or maybe the total width of our parabola is 2 meters. What if we want to increase that? How do we go about doing that? So just to emphasize, what I'm going to do is I'm just going to get into a new color pen, maybe the green one, just to note what happens. So maybe we want it this long now. So that's how long we want it. We can see the maximum is still the same, and we can see the minimums or the lower values of the parabolas are still the same. But the only difference is this chord here is now d meters extra. So the x value will be 10 plus d, and the y value, well, that's unchanged. That will still be 7. So that'll be the coordinate of that unknown point. It's 10 plus however long the total distance needs to be. And the vertex up here, so we do need the vertex of that. I'm just going to rub out the previous coordinate to give us room to do our working. So that coordinate, well, if you think about it, that coordinate is going to be in the middle of that parabola. So the x value down here, that will be the midpoint. And we can calculate the midpoint by going 10, which is the first x value, plus our generalized one, 10 plus d, and that's the second one. And we're then going to divide that by 2, and that becomes 20 plus d divided by 2. So that's the x value. You could also simplify that again. That could be 20 divided by 2 plus d divided by 2, which is 10 plus d divided by 2 as well. So you can use whatever one. I'll use that last one just to help the maths easier later on. So that means that point there, it has an x value of 10 plus half the distance. And the y value, that's still the maximum there. So that hasn't changed. That there is 10. Okay, and that then is enough information. So we've got a vertex coordinate, even though it's in generalized form. We can actually go ahead and calculate what the final formula or generalized formula would be. So let's call this generalized because we don't really know what's happening. So generalized, well, how much has it moved up or down is the first question. So let's get that formula. Y equals x plus b all squared plus c. So see, how much has it moved up or down? Well, that's still 10 because the y value is 10. So c will be equal to 10. B, how much has it been moved left or right? This is the one that's conceptually a bit more difficult, but B is going to be equal to negative 10 plus D divided by 2. So it's the opposite, or the negative value, of that coordinate. And what we can do is we can put that together to form the first part of our generalized formula. So y is going to be equal to a x minus, and then, oh, hold on, let's put a close bracket there. Oh, funny, 10 plus d divided by 2, close bracket. So that's squared, and we're then going to add 10 to that at the end. And for simplicity, we're actually just going to expand that bracket there. So y is going to be equal to a x minus 10 minus d divided by 2 squared plus 10. So that's the first part of our generalized formula. So we've got b and c. Like a normal question, we now just got to calculate a. So let's carry on. Let's use that same point, 10, 7, to do that. So at 10, 7, we know that x was equal to 10 and y was equal to 7. And we're going to put that value into our formula. So hopefully I've got enough room for working down here, but if not, I'll move up to the top there. So we're going to have 7 is equal to a, and then in brackets x minus 10 minus d divided by 2 squared plus 10. We're going to substitute the values in that we know. So y is, oops, sorry, I've already put in the y. Let's put in the x value actually, or rub that out. So that x value, that's going to become 10, which I'm liking because we've got the 10 minus 10, which is going to make our equation simpler. So 7 is going to be equal to a times negative d over 2 squared plus 10. Let's move this plus 10 to the other side. So that's going to be 7 minus 10 is going to be equal to a times, so negative d times negative d is d squared, and 2 times 2 is 4. So that side is going to become negative 3 is equal to a times d squared divided by 4. Let's move that to the other side. So a is going to be equal to negative 3 divided by d squared divided by 4. A is equal to negative 3 times 4 over d squared. A is therefore negative 12 divided by d squared. And that's our a value. So even though that's not an exact mathematical number, it's a generalized number that we're happy with because it's with reference to d, which is the total width or distance of the parabola that we are looking for. So we can then finish up in the top left corner. We'll be able to write down our generalized formula that pulls in a, b, and c with reference to d, the total distance. So therefore, y is equal to negative 12 divided by d squared. And then in brackets, we've got x minus 10 minus d over 2 squared plus 10. So that's our generalized formula. The last thing to note is either the domain or the range. Because we're changing the d value, we don't really know much about the domain because that's going to change based on however wide we want the parabola. But we do know a bit about the range of the graph, we're looking for our parabola to stay between y values of 7 and 10, so that will be our range. So that means values of y should be between 7 and 10, and that there would be our generalized formula. So what I'm going to do is I'm quickly going to get onto Desmos just to show us what exactly this generalized formula means, and then we're going to get into that trig graph as well. Okay guys, we're in Desmos. We've got the original formula, and just noting I did add the domain of that graph. I forgot to do that during our working. And we've now got our generalized formula with the limited range, with d being the total distance or the width of the parabola that we're looking for. And what I've noted is I've just got d equals 2 because that's what the original parabola was. So the original parabola was 2 meters wide. And what we can see is we can only see the green graph, and that's because it's the exact same as the white graph, so it's covering it up completely. But let's say we want the distance only to be 1 meter. What we can do is this is what it looks like. We can see the graph has moved down. It's got a width of 1 meter. It's still at y equals 7, and the maximum is still at y equals 10. So what we've done is, if we added in 1, that would have changed it to that formula. And again, if we wanted it bigger, we can see how the bigger the distance is, the wider the parabola gets. And that's perfect. That's exactly what a generalized formula is. So this is what the parabola would look like if it was 10 meters wide, because it would be negative 12 over 100, x minus 20. Oh, sorry, x minus 15, and you can see the vertex at 15, and then plus 10, it's up there as well. So that's the point of generalizing. You can even make it negative. I'm not sure why you'd want to do that, but there you go. Okay, so what we're going to do is I'm going to pause the video. I'm going to go back to PowerPoint, and then we're going to get into that sine graph, or the trig graph, not sure which one it is yet. Okay, guys, we're back on PowerPoint. One thing I did note is I did forget the domain of this graph, so that's x values between 10 and 12. So I just thought I'd note that in there. And that there looks like my final answer, my start to finish of getting the generalized formula. So what I'm going to do, make sure you get this example down, make sure you understand it step by step. I'm going to pause the video, I'm going to clear our working, including all our doodlings on the graph, and we're going to get into generalizing that trig function. Okay guys, we're back. Our video is cleared, our sport is cleared. Let's get into the trig graph now. So I suppose the first start is let's come up with the regular formula for the trig graph. And I suppose the first step, you've got to think about it. Do you want to use cosine or sine? And normally what I do is I try to find the very middle of the parabola, or the very middle of the trig graph, where the values are would be at 0 if it was there. So that means it's there, and make sure it's going in the upward direction, which means we found a point, which means I'm probably happy to use the sine function. So a sine, open bracket, b square bracket, x plus c square bracket, close bracket, plus d. So we should be able to just observe all our information. So the d value, that relates to how much it's been moved up or down, which I've got that line there. So that should be at 0, and it's now at 4, which means d is equal to positive 4. Okay, the c value relates to how much it's been moved left or right. So as I mentioned, if we're using a sine graph, that upward bit should be at 0, 0. And so that means it's been moved all the way across to 10. And what here, I'm also going to make an assumption. Let's assume we are working in degrees as well. So that's gone across 10 degrees. So that means C is going to be equal to negative 10. We've now got to move on to the B value. So the B relates to how many cycles fit within our, because we're doing degrees, 360 degree cycle. So B is going to be equal to 360 divided by the length of the cycle. So if you have a look, we start at 10 and we finish at, that appears to be 19. So that means it has a distance or a period of 9, which means D will be equal to 40. Oh, sorry, I've written D, but that should be B there, shouldn't it? B. And finally, A value, that relates to the amplitude. So have a look. From the middle, it goes up to it also goes down 2, which means that amplitude is 2. So that means A is going to be equal to 2. So we're able to put that all together to come up with our regular good old trig formula, particularly using sine. So I normally always use sine because I find it easier to identify that point where the 0, 0 point going upwards. Okay, so that means y is equal to 2 sine 40 c minus, it is x minus 10. That should be, because c is negative 10. And then we've got a close bracket plus 4. So that's our formula of that. So don't forget, you do need to consider the features and write them out in words like I did. Oh, I didn't. And that is for values between 10 and 19. So between x, minimum must be 10 and maximum must be 19. So that's the regular formula. So how do we come up with that generalized formula for this one here? So we're now going to focus on the generalized. And I guess the key thing to note is currently this here has a distance or a total revolution of, we're going to call it 9 meters. But what if we want to change that? What if it's now only d meters? So we need to think how that's going to affect our parabola. So what I'm going to do is I'm going to pause the video. I'm going to clear some of our working on the graph so we can get into that a bit more. So let's create a new one. So let's say it's going to be shorter this time. So our start point, well, that's not going to change. That's still going to be 10, 4. Our end point, so the amplitude staying the same. It's still got a height of 2 and it goes below 2. So that's the same. The period, that's going to change because it's now no longer 19 units. So that there will be different. So we'll put a little star next to that one. C, that relates to how much it's been moved left or right. That's still the same because it's still starting at positive 10. And D relates to how much it's been moved up or down. That is also unchanged because it's still been raised 4. The only other thing that could be changed is in the domain, I'm circling 19 because it's not going to stop at 19 now. It is going to stop at another point. So in our formula, we will be looking to change the B value and the domain for that. So let's write down our generalized formula or our typical formula. So A is equal to sine B x plus C plus D. As we've noted, the amplitude, that's not going to change. That's still 2. The D value, that's still 4. And the C value, that is still going to be minus 10. But what has changed, or the first one, is the B value. So B is going to be equal to 360 divided by how long it takes to complete a revolution. And in our case, that revolution now takes D units, or the distance is D. So 360 divided by the distance. So that means our new formula the only thing we're going to be summing out is that B value, and we'll get to the domain in a bit. So that means our generalized formula, y is going to be equal to 2 times sine 360 divided by d. Obviously, if we were in radians, you'd be doing 2 pi divided by d. That's x minus 10 plus, close bracket, plus 4. So that's the generalized formula. The only other thing we've got to limit is the domain. So it's still going to be for values between above 10, but that is going to be stopping at 10 plus d because we want to increase it by the total distance. So the trig one, a lot easier to work out than the parabola one. And hopefully that makes sense. So what I'm going to do is I'm going to pause the video. I'm going to switch to Desmos just to show us what this generalized formula actually does. Okay, guys, we're back in Desmos. You'll see our original equation up the top with the domain of between 10 and 19. Sorry if you're hearing the noise in the background. That is a bunny rabbit who loves scratching on stuff. And related to that, if you're still listening, the code word for today's video is rabbit. So put that down in the comments below. We'll be able to see who's listening. The next one, y, our generalized formula, and we've changed it for our new b value, 360 divided by d, and we've changed it for our new upper limit of our domain, 10 plus d. And our original distance was 9 long per the graph and the PowerPoint. And what we're going to do is we'll just show us if we want to make this smaller, we should see the highest points, well, they should be staying at 6 and 2. But we should see that graph shrink down as we change it. So let's have a look. There you go. So we can see it shrinking down. And what I want to note is the big issue, what a lot of people do forget is this part of the domain. So if you left that at 19, what would happen is that would just be a little bit incorrect because you would see it's actually adding frequencies. So it hasn't generalized the model. It's adding full revolutions, which isn't what we're wanting. That's not what we're going for. So what we're going to do is we're just going to leave that and we're going to put that back to 10 plus d being the correct domain, and then the graph shrinks with it as opposed to staying at that 19 value. So hopefully you found this video on generalizing useful. It was a video on the longer side, but a really important skill, particularly if you're aiming for excellence. But don't forget, this is just the maths or the numbers behind it. Your graph and the features of your graph must be fully justified based on the context, and you should be linking the features of your graph with that context as well. So don't forget the code word. Good luck, and hopefully you go really well for your internal.